Our topic in Math 10 for second quarter in week 1, graph of polynomial functions. Cardiac investigations can be done just using the electrocardiogram. It can provide useful information in the assessment of cardiac patient. When doctors advise us to undergo into the electrocardiogram, the result is in the form of a graph, just like the doctor can easily interpret the graph. In this lesson, we will be dealing with the graph similar. One method of finding the zeros of a function is by drawing the graph. Then we know that for the first degree function, the graphs are straight line. And for the second degree function, the graph is parabola. Then the graph of a polynomial function has the following characteristics. If the leading sign of the coefficient is possible, the graph ends up, and if negative, the graph ends downward. The polynomial n is less than 2. At most, n is negative 1. Number of turning points. The number of times the graph of polynomial degree n crosses the x-axis. At most, n points. The graph of polynomial function is a smooth curve with rounded corners and no sharp corners. Okay, so like for example, example number 1, draw the graph of the following. We have the function of x is equal to open quantity x positive 1 close quantity. Then we have open quantity x negative 2, then close quantity. Then open quantity x negative 4, then close quantity. First, determine all the zeros of the polynomial and their multiplicity. Okay, so we have f of x is equal to, we have here x plus 1, then we have here x negative 2, then we have here x positive 4. So, we have x positive 1 is equal to 0. So, we have here x is equal to negative 1. Then, we have x negative 2 is equal to 0. So, x is equal to positive 2. Then, next, we have here x negative 4. So, x negative 4 is equal to 0. So, therefore, we have here x is equal to positive 4. Then, after that, since the function is in the third degree, the graph crosses the x-axis at most 3 points. Also, the graph has at most 2 turning points. Then, after that, determine the Y-intercept. So, we have f of x is equal to, we have x positive 1, then we have here x negative 2, then we have here x negative 4. Then, we have 0 plus 1. Okay, next we have 0 negative 2, then we have here 0 negative 4. Okay, so then add. We have 1 Okay, okay, add positive 1 plus negative 2 plus negative 4. So the result is, we have here 1, negative 2 plus negative 4, that is negative 6. Okay, so then add, so that is, so is equal to negative 5. So next, determine the Q more points. Then we have to find f of 0, f of 1, and f of 3. So we have here the solution. So f of 0 is equal to, so we have 0 plus 1, then we have 0 minus 2, then we have 0 minus 4. Then simplify. Okay, so first, okay, we have here 1, multiply it by 1. So we have here negative 2 times negative 4. The result is positive 8. Then we have is equal to, multiply. So 8 times 1. So we have the result is 8. So the coordinate is equal to 0 and 8. The next, f of 1. So we have here 1 plus 1. Then we have here 1 minus 2. Then we have 1 negative 4. Okay, then simplify. We have 1 plus 1, that is 2. Then we have negative 2 and positive 1. The result is negative 1. Then we have here positive 1 and negative 4. The result is negative 3. Okay, then we have here 2. Negative 1 times negative 3. The result is positive 3. Then multiply. We have 3 times 2, the result is 6. So therefore, we have the coordinate or the ordered pair is equal to 1 and 6. Okay, next. So if 3, f of x is 3. So we have 3 plus 1. Then we have here 3 minus 2. Then we have 3 minus 4. Then simplify. 3 plus 1, that is 4. Then we have positive 3 and negative 2. The result is positive 1. Then we have negative 4 and positive 3. The result is negative 1. Then solve. 4 times 1, that is 4. 4 times negative 1, the result is negative 4. So, we have the ordered pair or the coordinate is positive 3 and negative 4. Okay, so we have the coordinate points. We have 0 and 8. 0 is the x-axis and 8 is the y-axis. So we have here the point. So meaning, your x-axis is 0, then your y-axis is 8. Then, to interpret this graph, so, turning point. Now, the turning point is 0 and 8. Then we have another point. The coordinate we have 1 and 6. 1 and 6. Then, next is we have negative, your x-axis is 3, then the y-axis is negative 4. So, negative 4, and we have positive 3, the x-axis. So, this is now the turning point going up. Then, this one, this is the turning point going down. Then, this line, to interpret this line, so this is called the Y-intercept. This is called the Y-Intercept. So, the form of the graph of the polynomial is a curved line. Our activity in Math 10 in second quarter for week 1, determine the x-intercept and the y-intercept of each given polynomial function to obtain other points on the graph. Find the value of y that corresponds to each value of x in the table. Write your answer in a yellow pad paper.